hard to solve. A small block of mass 2m, and it's algebraic too, which adds a little level of fun. Initially, it rests on the track at the bottom of a circular vertical loop-the-loop at the radius r. The surface between the block and the loop is frictionless, yay. The bullet strikes the mass m horizontally with the speed v naught and remains embedded in the block. So what type of collision? Inelastic collision. Energy is conserved? No. Elastic collisions are the only ones where energy is conserved. Energy is lost in this type of collision. Determine each of the following in terms of m, v naught, r, and g. Speed of the block after impact. What type of problem? Momentum conservation. Two objects colliding, it's momentum conservation. mv plus the second object equals m1 plus m2 times new velocity. Two objects before, they combine and make one object afterwards. The bullet has a mass m with a speed v naught. This has a mass of 2m with a speed of nothing. So together they have a mass of 3m and some new velocity. mv naught equals 3m v prime velocity of the block bullet combination is v naught over 3. So conservation of momentum question. Just go through the steps for conservation of momentum and you come up with that. v naught over 3 equals v prime. The kinetic energy of the bullet and block when they reach point P on the loop. What type of problem? Conservation of energy problem. So conservation of energy problems are solved first by identifying starting and finish. Start here, finish here. Start when it becomes a bullet-block combination. Before that, all the physics for a bullet-block combination don't work because there wasn't a bullet and block. So we have to start where that starts. Identify the start and stop. Identify the types of energy. What type of energy at position 1? Kinetic. Type or types of energy at position 2? Kinetic and gravitational potential. So, we set up our conservation of energy equation. One half mv1 squared equals 1/2 mv2 squared plus mgh at point 2. Mass. Good. Velocity at point 1. v naught over 3, quantity squared. Velocity at 2 is what we're solving for. Gravity and height at 2. That's r. So solve for v2. 1/2 v naught squared over 9 equals 1/2 v2 squared plus g. Oh, just the kinetic energy. Oh, why didn't we say that? That changes everything. Well, not everything, but yeah, it makes it significantly easier. Why not solve for the velocity? We're almost there. Fine. That's true. We would get the problem wrong. I wonder how many people solve for velocity. What did we say this was? v naught over 3 squared equals k2. Let's leave it there. That's the kinetic energy. Plus mg r. So 1/2 m v naught squared over 9 equals K2, forget it, minus mgr equals K2. Three mgr. Because the mass is 3, yes. Minus 1 for me. Actually, minus the whole thing for me since I solved for velocity instead. I guess we can leave it like that. mv naught squared over 18 equals minus 3 mgr equals kinetic energy at point 2. It may be attractive when you simplify it, but that's fine. Did I do that wrong? Is that all right? You can tell me if I got it wrong. Better? Better. Thank you. Yeah, I forgot 3m over here too. This is 3 too. Little mistakes. We're trying to go too fast with it. Minimum speed if the bullet and the blocker successfully execute a complete circle. But where is it most likely going to fall off? At the top. So in order to be on the surface at the top, what are we looking for? A normal force. When the normal force equals 0, lost contact. So we want the normal force to exist at the highest point, or what we're going to solve for is when it doesn't exist, at what speed. So we're solving for normal force. Always use a free body diagram first. What's the free body diagram look like at the top? Where's normal force? Same as gravity as well. So sum of the forces equals ma. It's a circle, so it's c's. Normal plus gravity. They are both positive since the acceleration is downwards. Equals m v squared over r. Substitute AC for v squared over r. We're going to find it when the normal force is 0. That'll give us the minimum speed in order to get all the way around. I always forget my 3's. Fortunately, that makes no difference. GR root. Oh, it's clean. Oh, it's a wild ride.